Hey everybody, how's it going? Dylan here, and I'm going to be giving a shot at my very first tutorial. Right now we're going to be covering the NavMesh, which is used to control AI characters' movement in Unity. So first I'll talk about what the pros and cons are of the NavMesh. Uh, Basically, from my experience, the pros are like the NavMesh. It's there and it's ready to be used, so you don't need to worry about creating your own algorithms for navigation, which for beginners is extremely useful. There's lots that you can actually do with the nav mesh. It just requires a lot of scripting to make everything run smooth, and we'll cover that in the later portion of the video. Uh, so I guess let's just jump into it. So you see, I have a little test scene right here. It's nothing fancy. I got a few game objects. The black ones, the black game objects, the black rectangles, are used to show you what the enemy is trying to avoid. The enemy being this little guy right over here. It's just a cylinder game object, nothing fancy, and the player, which I'm going to be controlling, is this little box here. So it's nothing fancy. It's just a test scene to get everything to get the nav mesh across. So first of all, to open up the navigation, the nav mesh, you go to Window, the top of the screen, and you mouse over the navigation button here and click that, and it'll open this side window right over here. Mine was already open, but you'll be taken right over here. So the important things in setting up a nav mesh in this little window to your right will be, first of all, the object here, the object tab. And so if I click an object, you'll see that the navigation I've set to static. And then if you go down here to the navigation area, I've set it to not walkable, which means when I actually go in and I bake the nav mesh, which it's not hard, it'll make it so that that area right here where this game object is, the AI cannot walk through it. So he'll have to try to find if the player goes to the other side of this game object, the AI will try to find a different path around it. We're not going to really cover off mesh links. That'll be more of an advanced video that I might do at a later point. So we're not going to cover everything right now. It's just the basics. So we got a couple other ones here. So navigation area jump, which means when the player or the AI comes to this game object, he can actually jump over instead of not being able to walk through it. I mean, it's pretty basic. There's not much here. That is, you can turn that off. Generate off mesh links. I don't know why that was on. It's not necessary for this, but I mean, it's very basic. The terrain, obviously, you want to set to navigation area to walkable, but yeah, I mean, it's not complicated. Any object that you know is not going to be moving in the scene, and you want the enemy to avoid it, then you need to set that object to navigation static. Because if you don't set it to navigation static, the enemy is going to be able to just walk right through it, and for most cases that's not so good. I wouldn't set navigation static on fluff items in the level, kind of like maybe plants that are in the way. I wouldn't set that to navigation static because that would just the enemy can walk through the plants or whatever. It doesn't matter. I'm kind of rambling on right now, so we'll get back on the topic. So yeah, that's pretty much the important part of the object. Just make sure you set everything to navigation static, and if you want them to be able to walk through it or not. So we'll go over to the Bake tab, which is the second tab, and you'll see you got a couple different things here. Let me click this. So the radius, you see this little green collider around the enemy. no, sorry, that's incorrect. The agent radius. You know what? I'll bake this here. So yes, you see the blue areas that are now on the map. That is what the player is able to, or not the player, sorry, the enemy is able to walk over. If there's no blue, the enemy can't walk there. He's got to stick to the blue. So if I change the agent radius to a higher number, watch the blue areas when I bake it in and see how that affects how it affects it. So there's a lot less. The higher the radius, the further away from the game object will be an area that is not walkable. So if I reduce that down to something like 0.2, you'll see that there's a lot more space for the enemy to walk, which for the tutorial is what we want. Agent height, which is right below the radius. You see this little guy right here? Let's get over there. He's actually off the ground. Now, if I reduce the height, let's say to something like 0.5, the area underneath him, when I hit bake, should turn blue, and he'll be able to walk through it. So basically, agent height is how much, it even says right here, how much vertical clearance space must exist for the NavMesh to actually generate a NavMesh underneath that. We're not going to worry, again, under here with the generated off-mesh links, the drop height and jump distance. Just don't worry about that for now. I guess I will cover step height, though. So step height, if I set that up higher, that's just something ridiculous. What I should be able to do is if I set this guy to walkable, he's already set to walkable, so now there will actually be a NavMesh coming. I'll just show you. Nope, wasn't high enough. Let's just set it to something ridiculous. Or not. I'm not sure that should work, but you know what, I might leave that in for the advanced video. Step height should be less than the agent height clamping. Okay. Right, so let's reduce that. Alright, there we go. So basically, the issue there is that the agent height was lower than the step height, which should not be. But now everything works. So you see this guy right here, the red indicates that when he gets there, he's actually going to jump over that area. And this, you know, there's no blue, or there's no white here anymore, which means he's actually going to try to step over this object. But let's take that back down. We don't want that. That's just for. That's just for me showing you. So there we go. This is our final testing. Alright, we're not going to worry about areas. That'll be in the advanced video. But there is something else I need to show you. So we're going to go over back to the inspector. Now, the enemy here, one thing that's required to make them move is a component. So we'll remove that. Go here, we'll add a component called the NavMesh agent. Oops. I can't even spell right now. There we go. NavMesh agent. So you see we have a bunch of stuff here. We're not going to cover it all, but the radius is what I was talking about earlier when I made that mistake. You see the little green area? That's the radius. The extents of the radius cannot be in the white area. So this right here isn't going to fly. So I'm going to have to reduce the amount, or the size of the radius, so that it's not inside the white, or else it's not going to be able to find a path to the player ever. So there we go. We got a good size there. The height is how much vertical clearance is needed for the actual NavMesh agent. So if I set that to a ridiculously high number, the NavMesh agent isn't going to be able to walk underneath this thing, even if there is a blue area, just because it's set to too high of a number. So we'll reduce that. We want him to be able to walk underneath that in some cases. Base offset is actually aligned to the pivot of the player. So if I reduce that to a negative amount, you see how it starts going up? 0, set to 0 right now, which is aligned perfectly to the bottom of the pivot right there. If you can see that. 1 is actually a pretty good number, so we'll leave that, but that's something to play around with if you need to adjust where the actual NavMesh agent exists on your game object. Alright, so we'll go down here to speed. Speed is how fast your player will actually move. So right now it's 3.5, which isn't really fast. You can really crank that up for whatever needs you have. You can crank that up. Angular speed is how fast the object will actually rotate. So when it needs to rotate its forward to face the player or its target destination, that's how fast it's going to do that. Acceleration is how fast it accelerates up to the speed, the maximum speed that you have set. So for when I'm using characters that have a walking speed, there's not really like an acceleration when you start walking. You kind of just go. You don't accelerate to a faster speed. So I usually just make sure that the acceleration is set higher than the speed. If you're maybe doing a game with cars, then you would want an acceleration speed. But for the most part, if it's just like a walking thing, you probably just want to set that higher than the speed. The stopping distance is how close the object will stop in accordance to the player or its target. Sorry, I keep saying player, but it's actually the target destination. It is good to note that it's not just going to stop on the player if you have the speed set too high. The way that the NavMesh actually moves the player, or the enemy, sorry, is with velocity. So it's actually going to have a deceleration rate. And there's ways to combat that, obviously, in script, and I will cover that when we open up Visual Studios here. But that's just something to note. Auto braking here, just make sure. If you don't have that set, it's not going to brake. So you're going to want to have that set for the most part. We're not going to worry about obstacle avoidance or pathfinding. All that stuff is in an advanced video that'll be coming at a later date. But for the most part, you have everything that you need right here. So I guess let's just get into the scripting. I'm going to remove the component that I have right now. I was setting up my test scene, making sure everything worked properly, but I'm going to be scripting from fresh to kind of guide you guys through it. I do have a character controller here with very, very rough controls. Like it's literally just for testing. So don't, just set up some crappy controls for a character that moves them if you want to test it out. But yeah, I guess let's just jump into it. I don't think there's anything else that I really need to cover. Just make sure that when you have the test scene set up and you have every object set to what you want, navigation static, and if it's walkable or not, you click on the terrain and you just hit bake. And then, so if I hit clear, it'll clear the NavMesh and nothing will happen. If I hit bake, it'll set it back up. So just be mindful of that, set that up properly. But let's jump over to Visual Studios and start scripting, I guess. Alright, let me make sure that works. Okay. So here we go. We're going to be using C# for this. But the way I like to program is with a lot of public variables, so that during runtime you're not searching for stuff, or you're searching for stuff as minimal as possible. But what we need in the NavMesh agent is actually a target. So instead of public game object, oh, I'm actually getting mono behavior issues, so I'm going to have to restart Visual Studios real quick to refresh that. It's something that happens to everybody. There we go. As soon as that comes up and everything works, let's make sure. Alright, and we're good. Public game object. Yeah, so if you don't know that, what actually happens is IntelliSense breaks quite a bit, I find. So you're going to have to just, if you ever see mono behavior as white, or anything like maybe it's not finding game object as something. So if IntelliSense isn't finding game object or something like an integer, just reset Visual Studios, you'll be good. But we'll set public game object, we'll call it target. Alright. And basically what we're gonna do is, just to get it started, we're gonna do, actually let's do this too. Let's create a NavMesh agent, and we'll call it agent controller. And in the start, we'll make agent controller equal to get component NavMesh agent. And since the script is going to be attached to the AI, then it'll just get the component of NavMesh agent on the AI if it actually has one, which it will. So down here, we'll just get it started. We'll set agent controller dot destination is equal to target dot transform dot position. Alright, so let's jump over back to let's jump back over to Unity. So we'll go to the inspector, we'll click our AI here, and we'll add the NavMesh to, it's not even, we'll just click and drag it, it'll be easier. NavMesh tutorial script. And we'll take the player, which I believe is this guy right here, and we'll just drag him into the public game object that we made for target. And if I start this up, we'll hit play, the NavMesh agent should start walking towards the player. There we go. And I can actually move, and he'll continuously try, because it's in the update function that we're setting the destination. He will continue to come after me. There we go. Easy peasy. Alright. So, I mean, as you can see, it's very basic to get the NavMesh up and running. There's a couple things that we can actually do to kind of improve the behavior a little bit. There's some checks, some fail-safe checks that we're going to want to use in order to check if the player is actually in a position for the AI to reach. And I'll actually cover that right now. So what we're going to do is we're going to create a NavMesh path. And basically what I'm doing right now is I'm checking to see if the player is in a path that the AI can reach. So we'll go NavMesh path. And in the update, we'll do path equals new NavMesh path. Alright, and there's a function that we're going to want to call on the agent controller called calculate path. And it takes in a target position, which in our case is going to be... Sorry, I actually need to run... I'm going to delete that. I'm going to need to put it underneath here. And in our case, it's going to be the agent controller dot destination, and we're going to pass in... It also takes in a NavMesh path, so we're going to pass in that path object that we just made. And so what calculate path actually does is return true or false. It returns true if there's a path available, and it returns false if there is no path. The tricky part in this is that there's two scenarios where it can return true. So if you see that I put the player over here, and we'll go to the NavMesh agent. With the player on this side of the game object, there's no way for the AI to reach the to actually reach the player, but he'll still make an attempt, and we'll watch where he goes. He's gonna stop right at this block right here. He can't pass it though, and basically what that does is it returns, if you look here, agent controller dot path dot status will equal now. Well, we'll just do this. We'll debug it so you can actually get a visual for what's going on here. I want debug logger. Debug log. So it'll be returning path is partial. See? Right here. It's continuously returning that the path is partial, which means essentially that the AI can only make it a certain distance, but he can't complete his path. We'll go here. We'll move the AI or the player to the other side, and it won't return path is partial anymore. It'll only return path is complete because the AI can actually control or completely finish its path. Okay, so we don't need that anymore. But if the path is complete or the path is partial, calculate path will still return true. If the player is off the NavMesh and there is physically no path available because the player is no longer in reach of the NPC, then it's going to return false. But that's not really, we're not looking for true and false here. We only care if the path is partial in this specific scenario. It may change depending on what you're using your NavMesh for, but in this scenario, we only care if the path is partial or if the path is complete. But that's where this path comes in. So what we can actually do is check if path dot status is equal to path is NavMesh path dot. I'm not getting this right now. NavMesh path status dot path is partial. Then what we're actually going to do is come back up here for 1 second and create a vector3 start position. We're going to make the start position equal to the game object dot transform dot position, and then we're going to set down back underneath the path partial check. We're going to do agent controller dot destination dot destination equals start position. And now he shouldn't move. He'll just stay there until the player actually, just drag him over there, I'll cheat. Actually, yeah. There we go. Then in theory, if oh, he broke me. I'll try that again. Alright. So we'll start on the path is complete this time. So he's actually coming at me right now. We'll pause that. Drag it over here. And now he's going back to his original start position. I'll pause that. Come back over here. He's going to start coming towards me. Pause that. Bring it back over again. And he goes back to his start position. So there's actually quite a few things you can use that for, and I'll give you a specific example of a project that I'm working on right now with a team of 8. Um, our AI, we have waypoints set around the player, and our AI will select one of those waypoints depending on how many AI different characters or different AI units are actually selected on that waypoint, and it'll choose the lowest amount of waypoint. Or sorry, let me try that again. There's an enemy count on each waypoint, and anytime an enemy targets one of those waypoints, it increments that enemy count by 1. And what the enemies will do is try to find, if they don't have a target yet, they'll try to find the lowest one. But what happens if the player is up against a wall and one of those waypoints is now outside of the target destination, or outside of the path, and it's going to return path as partial? I'm going to want to use this to try to find to find a new waypoint, to make that one that's outside of the path. I'm going to want to use this to find a new waypoint. So it's actually very useful. You just have to make sure that you're using path right here, and you want to make a new game object. Another tip that you can do is if you want the player to slow down. So we'll go back into the scene here, and we'll set the stopping distance to, let's say, 2. And then I'll drag the player back over here. Oops, let's restart that. I didn't realize I was in play mode there. So we'll go back and we'll set the stopping distance to 2. And we'll see what happens. Alright, so he stopped right on the player, but if I increase the speed and the acceleration, let's just crank this up. You see how weird that acts? It's a little too fast. I'm gonna just do something like this. 20. He's now on top of the player because the deceleration wasn't fast enough to actually stop him before he got on top of the player. So something that I like to do is this right here. So we'll do another if check. If distant, or if vector3 dot distance, and we'll pass in the agent controller dot destination as the first variable, and the game object dot transform dot position as the second variable, and we'll check to see if that is less than or equal to the agent controller's stopping distance. And if it is, if that returns true, then we'll set the agent controller dot velocity. Make sure it's actually the agent controller velocity that you're setting and not the rigid body. NavMesh agents don't actually need a rigid body unless you're going to be using collision, but you want to make sure you're affecting the NavMesh agent velocity. So now agent controller dot velocity is equal to new vector 3 0 0 0. Okay. But we're gonna want to save the original speed of the characters. So vector 3 save speed. I can't think of the word, but save speed. So save speed is equal to agent controller dot speed, or no, that doesn't matter actually, because we're not affecting the speed, we're affecting the velocity. I did it a little different than I normally do, but we'll see how it works. So there, he stops right away. Now that looked kind of funny because he was going extremely fast. But when you start increasing the scale of your game, and that won't look as fast, but it'll still have the same problems. So that I find is a good solution. What I normally do is I actually just change the speed, but this works a little better because I should be able to. Yeah, you don't even need to worry about saving the speed. He's a lot faster than I am, so he starts and stops. But I mean, you get the gist of it, right? I think, what else is there to talk about? I mean, that was pretty much all I wanted to talk about um, in this. One thing to actually consider, though, when you're calculating the path, and I forgot to mention this, when you're doing calculate path, it's a very expensive operation. So you might want to have some countermeasures when determining the path, because you don't want to run that. Say you don't want to run that 60 times a frame, you know, or you don't want to run this every single update call, because that's going to seriously, when your game starts going and you have a bunch of these going at the same time for different AI controllers, if they're all running on the same frame, it's seriously going to bog down your game. So you might want to come up with some countermeasures, like, I don't know, this is just a very ghetto way of doing it, but we'll create a timer and we'll set it to 0. Okay, and then we'll set another timer to check check path, and we'll set that to like I don't know, 0.5. 0.5 F. Okay, and I guess right here we'll just do if timer is greater than or equal to check path. Alright, and then we'll do timer plus equals time dot delta time. And so now it's not gonna calculate the path every single second. You're not gonna notice anything in the game, but basically it's not gonna check the path every single update call unless timer.delta time or timer is greater than or equal to check path. One thing I did forget to do is, and this is a common mistake I make all the time, you need to reset timer to 0, or else it'll never go back inside, or it'll then after the timer is greater than or equal to path, it'll just always be checking that. So you gotta make sure you reset timer to 0. But other than that, I mean, this is just a very basic video because there's a lot you can do with the NavMesh, but a lot of the problems I had when learning it came from figuring out how to properly use the calculate path, because I couldn't see the code inside there. But once I figured it out, it honestly, it works wonders. And like I said, the pros is that the NavMesh is here. It's available to use, and so you don't need to worry about making your own algorithm. I guess one of the pros to making your own algorithm, your own navigation algorithm, is that essentially you could make it more efficient than Unity's built-in navigation system, but for the most part it's not bad. One thing that does kind of suck is when you have a big scene and there's a lot of objects that you need to set to navigation static. If something goes wrong, and for example, for our game that we're working on right now, I have to go through about 1,000 tiny little rocks, and I need to set them to navigation static and to not walkable, because we added something that just messed everything up. So that's one of the drawbacks, but that's it's definitely doable. It's just tedious. It's a little boring, but there's nothing really else that I can think of. I will come back at a later date and cover the nav or the off links, but that's basically for connecting two pieces of two nav meshes that aren't or two obstacles that aren't connected by a nav mesh. So for this situation right here, if I generated nav mesh off links and set variables to be proper, then you could actually just jump over there, jump over this game object. But that's for a later date. This is probably dragging on for a little bit too long, so I'm going to end it here. Thank you for watching my very first tutorial, and I hope I ramble on less for the next one. I feel like I did that a lot here. Anyways, take it easy, everybody.